Question number 26. It says a massive frictionless cylinder of radius r moving with a constant velocity u1 collides elastically with a small light ball moving with a velocity u2 towards the cylinder perpendicular to its axis as shown in this figure. So this is a figure, and this is a cylinder which is moving in this direction with the u1 velocity, and there is a small ball which is coming towards this cylinder with velocity u2. This direction of u2 is perpendicular to the direction of axis of the cylinder. So cylinder is going into and outside of this screen. Further says the distance between the lines of motion, this is called impact parameter of the bodies, is b. So this u1 is along this line, u2 is along this line, so these are the parallel lines, so the gap between the two is b, that is called impact parameter. Find the speed of the ball after the collision. So this is going to collide, and then what will be the velocity, rather magnitude of velocity, or we can call it a speed of the ball we need to find out. Gravity free condition is to be assumed. So here I have written the solution. I'm going to explain it. Now crux point to catch is it's a massive cylinder, and this ball which is going to collide is light and small. So since it's light, that means its weight is very less as compared to the cylinder, and cylinder is massive. So we can think of the difference of mass between these two bodies is of high magnitude. That means if with a very heavy object, very small object, light object collides, then there is no change in the velocity of the heavy object. It's just like if we drop a ball on the earth. So due to the collision of the ball with the earth, there will be no significant change in the earth velocity or motion, right? So that's the point we need to catch up from this language, right? So we will claim that after the collision, this massive cylinder will not change its velocity. So after the collision, this massive cylinder will be moving with velocity u1 as it was moving earlier. Now, however, this ball, a small ball, which is small in size as well as light in mass, so this is going to collide like this. So this is the figure during the collision. When this ball is in contact with this, we can have this black colored line, which is line of impact, and then this ball is going to experience a momentum or impulse, you can think of, along the line of impact. Moreover, this cylinder is smooth, frictionless, so there will be no force acting on this small ball along this line which is perpendicular to the line of impact. So this was the initial situation of the ball, and this was u2 velocity. Let's consider this line of impact makes angle theta with the horizontal line. Then you'll find if we draw a line parallel to this line of impact here, so this angle is going to be theta. Now this u2 velocity can be made two components, one along the line of impact, another perpendicular to the line of impact. When this small ball is meeting this heavy cylinder, then you'll find the velocity which is perpendicular to the line of impact. In this direction, the ball is not going to have any momentum change or any impulse acting on it, because there is no friction available, so no force will be acting along the line which is perpendicular to the line of impact. So point is, this component of velocity, which is u2 sine theta, will remain unchanged. Why? Because we can say this small ball is our system, and we are conserving the linear momentum along the line which is perpendicular to the line of impact. So the mass of this particle or ball into this velocity must be equal to the mass of the particle into this velocity. That simply says these two velocities must be identical. However, this velocity, which was along the line of impact, and in this direction this ball is going to experience along this line, is going to experience an impulse. So that may change that may change its direction as well. So this v is being assumed as the velocity of the ball just after the collision. So just after the collision, ball will have these two components of velocity, and then the cylinder will have the u1 velocity, as I explained earlier, based on their difference in masses. Now we need to find out this v. Once we got this v, then we will say these are the two components of velocity. We can find the resultant, and we will be able to solve this problem. Now, as far as this question is concerned, this collision is concerned, this collision is elastic collision. That means coefficient of restitution, if we talk about, that has to be 1. Now coefficient of restitution is velocity of separation divided by velocity of approach. So velocity of separation along the line of impact we watch. So this velocity v is going to be of the ball, and then u1 cos theta component will come along the line of impact. So it will be like v forward this direction and u1 cos theta along the same direction. So velocity of separation will become v minus u1 cos theta, v minus u1 cos theta, divided by velocity of approach. Now approach was before the collision, so you'll find that this velocity u2 cos theta was along the line of impact and it was approaching for this collision. And this u1 was earlier as well, so u1 cos theta will be contributing to the approach. So total approach velocity is going to be u1 cos theta plus u2 cos theta, u1 cos theta plus u2 cos theta, that becomes equal to 1. Then after we can do this cross multiplication, find out v turn out to be these terms are going to have cos theta as a common, so it's like u1 plus u1 plus u2, that means 2u1 plus u2. Now we got v that was we were looking for, and then these are the two component of velocity. We can find out the speed. So speed of the ball after the collision is going to be, let's call it to be v2. v2 is going to under root v square plus u2 sin theta whole square, u2 sin theta whole square plus v square, right? Now v is this expression, so we can substitute over here. So it's like square of this entire stuff. So twice u1 plus u2 whole square into cos square theta, and this is going to be u2 square sin square theta. You can expand it. When you expand it, you will find u2 square plus 4u1 square plus 4u1 u2. Outside there will be cos square theta. Now if you collect this u square term, then you will have cos square theta plus sin square theta, that will become 1. So point is, you will get a u2 square separately, and whatever else you are going to get, that will have a cos square theta. So you can write like 4u1 square plus 4u1 u2. Outside the bracket is cos square theta. Now if we see this triangle, now this angle is theta. I have assumed this vertical gap between these two parallel lines is b, and this triangle is made over here. This distance will behave like radius, this perpendicular is b, angle is theta. From here sin theta can be written as b by r. We are requiring cos square theta, so cos square theta is basically 1 minus sin square theta. So 1 minus sin square theta, which is b square by r square. So final answer will be v2 is equal to square root u2 square plus 4. You can take this 4 common, so it's going to be within bracket u1 square plus u1 u2, and within the bracket this is cos square theta, which is basically 1 minus sin square theta, which is basically 1 minus b square by r square. So this is the expression for the speed of the ball just after the collision in this case. Okay, thank you.